Welcome back to Educator.com. This is Chemical Bonding Part 2. So, we took atoms and we made chemical bonds to form compounds. What we're looking at right now are binary compounds, which are compounds made up of two different elements. Not necessarily two atoms, but two different elements. Binary compounds can be ionic or they can be covalent. So if you take a look here, we have NO2 made up of nitrogen and oxygen. Like I said, it could be more than one atom. Right here we have two oxygen atoms and one nitrogen atom, but we only have two elements, which makes it a binary compound. N is nitrogen, O is oxygen. N and O are both nonmetals. So this is actually a covalent bond we made there. And this is a covalent binary compound. Na is sodium, Cl is chlorine. Na is a metal, sodium is a metal, chlorine is a nonmetal. So these two together are going to make an ionic binary compound, having only two different elements in it. What we're going to be using a lot today that we've talked about before is oxidation numbers. The oxidation number is the charge of the ion written as superscript, meaning above the symbol of the atom. So what I have here is this magnesium, and this 2+ here is our superscript oxidation number. We're going to be using that a lot in figuring out these bonds and how many of each element we need. The oxidation number is really important for that. Okay, so we dealt with making ionic bonds and making covalent bonds, which in turn makes ionic compounds and covalent compounds. So first we're going to learn how to name ionic compounds. When you name them, the name of the positive ion gets to go first, followed by the name of the negative ion. Okay, remember, ionic compounds are formed when a negative ion and a positive ion are attracted to one another and are held together by those opposite forces, those attractive forces. So we name with the positive ion first, the negative ion second, and you change the ending of your negative ion to IDE. So if your negative ion is chlorine, like this one, you're going to change chlorine, the ending changes to IDE, chloride. So what used to be chlorine, take away that ending and add IDE, chloride. If it was maybe carbon, you would change it to, take away that ending and add IDE, carbide. Okay, so anytime you see that IDE, you know that that's we're naming a compound. In this case, an ionic compound. So I have NaCl right here. Since we know we're naming ionic compounds, one's a metal, one's a nonmetal, it's ionic. The name of the positive ion is the sodium. Okay, and if you don't remember what the symbol and the names are, you can go back to your periodic table and take a look and look for the Na symbol, and underneath that you'll read that that's sodium. Na is also in group 1, which you remember the oxidation number for everybody in group 1 will be a +1. So that's how we also know that that's going to be the positive ion based on what group it's in. And we can actually fill those in before we get too far ahead of ourselves here. Okay, so group 1 with our hydrogen, lithium, sodium, K for potassium. These are all going to be our +1 oxidation numbers. Group 2 will be +2. Remember to skip groups 3 through 12, skip those transition metals, and head over to group 13, where the oxidation number is a +3. Carbon, in group 14, they can be plus or -4. Okay. And then we go to nitrogen, we start our negative oxidation numbers, -3. Oxygen is -2. The fluorine, group 17, -1s. And then, of course, noble gases, we're not involved here because since we're still talking about compounds, and if you remember, noble gases, for the most part, do not make compounds. They don't bond. They don't have electrons available for bonding, so they really don't bond. All right, so we have sodium and then the chlorine, which is our negative ion, which we knew from drawing in our oxidation number. change the ending to chloride. So there we have sodium chloride. The next one, our elements are magnesium and chlorine. If you go back, magnesium is in group 2. It's a positive 2 oxidation number, which means it's the positive ion. So it goes first. Magnesium. And then chlorine will be our negative ion, so it goes next. Change the ending to IDE. We have magnesium chloride. You see in both of these, the first two involve chlorine. The first one has 1 chlorine atom. Sodium chloride only has the 1 chlorine. Magnesium chloride has 2 chlorine atoms. For ionic compounds, you don't actually use these numbers in your description. You'll be able to figure out what the subscript should be based on the oxidation number. So we don't actually use any numerical prefixes like we will later. So the reason we know there's 2 chlorines is because magnesium has a positive 2 oxidation number, and chlorine has a negative 1. Okay? If you remember ionic compounds, they have to be balanced. So for a positive 2 charge, we also need negative 2 charges. And chlorine only gives us 1, so we know we need to add an additional negative charge on that chlorine. So we need 2 chlorines for every 1 magnesium in order to create a neutral compound. So we end up with 1 magnesium for every 2 chlorines. And what the subscript does is give us the ratio of how many magnesiums to chlorines we need. We draw that right here. Okay, so there's actually a shortcut to do this, and we'll look at that with the next one. We have Al, aluminum. S is sulfur. Aluminum is our positive ion, and actually the oxidation number is a positive 3. I'm actually going to write that out here. Al, positive 3, or 3 plus. And then sulfur will be negative 2. If you go back and take a look, it's in the same group as oxygen, so it has the same. Sorry, I've been writing plus 3 or 3 plus, and you really should write the number first, but it's okay. It means all the same thing, really. So I have aluminum with a 3 plus oxidation number, and I have sulfur with a 2 minus. That just means 3 positive charges and 2 negative charges. And I need to make sure that these are balanced. So I need to know how many aluminums to how many sulfurs will create a balanced compound here. So if I add another aluminum, I get another 3 positive charges. That gives me a total of 6 positive charges. So how many sulfurs with 2 negative charges do I need to get 6 negative charges? Well, the answer there would be 3. 3 sulfurs will give me 6 negative charges to create a balanced compound. And that's what I have here. For every 2 aluminums, I have 3 sulfurs. That's what you can see is written in that formula. All right, and so we have our positive ion. We know it's aluminum. And the negative ion is sulfur. Change the ending, IDE, aluminum sulfide. And just to give you that shortcut I was talking about, if I start out with my aluminum 3 plus and my sulfur 2 minus, we'll be doing this a little bit later, and I want to create ALS, and I don't know what my subscripts are supposed to be. I know I need to create a neutral atom, so I can figure it out this way that we did earlier, or you can take this shortcut where the superscript, the oxidation number of 1, becomes the subscript of the other when you go ahead and write it out in the formula. So let me just change colors so you can see this better. This 3, the number, not the charge, just the number, the oxidation number of 1 becomes the subscript of the other. So the 3 used to go with aluminum when it was a superscript oxidation number. Now it's the subscript for the sulfur. The 2 used to go with the sulfur as the oxidation number, and now it's the subscript for the aluminum. I'm sorry, this is a 3. I just drew it wrong, but I wrote it the right way. So that's how you get your Al2S3, creating a neutral compound. But for the naming, all you do is positive ion first, Negative ion second, change the ending of the negative ion to IDE.